In this video, we'll look at finding x-intercepts for some absolute value functions. Our question is, for each part, graph the function and find and label the x-intercepts. And we're given 3 absolute value functions. In the first one, we have +3 on the inside. On the second one, we have +3 on the outside. And on the third one, we have -3 on the outside. So for the first part, we have the function y equals the absolute value of x plus 3. So if we make a t-table, we see that our vertex will be -3, 0, which this matches our homework video 3.1.1. This is the graph of y equals the absolute value of x shifted 3 to the left. So since the graph of the absolute value of x is just shifted 3 to the left, there's only one x-intercept, and it's also our vertex. So we can see that our x-intercept here is -3, 0. For the second one, when y equals the absolute value of x plus 3, as we've learned before, we see that this is the graph of y equals the absolute value of x shifted up 3. So our vertex here is our y-intercept, and there are no x-intercepts because this function range is y is always greater than or equal to 3. You can see that here. And so the function will never equal 0. And for the third one, when y equals the absolute value of x minus 3, from our previous work, we know that this is the absolute value function shifted down 3. And when we graph that and look at our t-table, we'll see that we have -3, 0 and 3, 0 as our 2 x-intercepts. So let's check our work. Y equals the absolute value of x plus 3 is the absolute value function graph shifted left 3. The vertex is the x-intercept. And when we plug our -3 value into our function, we get 0 out. So this checks. When we look at y equals the absolute value of x plus 3, this is our absolute value function shifted up 3 along the y-axis. So this graph does not cross the x-axis, and there are no x-intercepts. The absolute value of x is always greater than or equal to 3. So if I add 3 to both sides, the absolute value of x plus 3 is always greater than or equal to 3. So the absolute value of x plus 3 is certainly greater than 0, no matter what x is. So no x-intercepts. When we look at y equals the absolute value of x minus 3, this is shifted down 3 units. And when we plug our values in, -3 and 3, we get 0 in both cases. So those are our 2 x-intercepts. So our answers are y equals the absolute value of x plus 3 has 1 x-intercept, -3, 0. Y equals the absolute value of x plus 3 on the outside has 0 x-intercepts. And y equals the absolute value of x minus 3 has 2 x-intercepts, -3, 0 and 3, 0.